In this video, we're going to be covering some of the best practices to follow in NestJs. So let's get started. Using pipes and DTOs for input validation. Anytime your route handler is expecting some payload from a request from a client, you should always make sure to validate that request data before actually entering the route handler. So for example here, we have a body that we are expecting from a request. We should make sure that this body object is sent in a correct manner. So to do that, we should use DTOs and pipes. First of all, DTO or data transfer object is basically a class with some properties, and it's used to specify the shape of the data that we are transferring in and out. Just by looking at this, we can tell that the product coming from the body has the product DTO shape, so name, price, and description, makes it more readable and cleaner. It also helps us with type safety. So if you take a look at create product, it expects a new product of type product DTO. So the data sent should have this shape. If you try and send something else, for example, age 10, we are going to receive an error. Age does not exist in type product DTO. So using DTOs is going to help us avoid errors and ensure type safety in our code. Using a DTO on its own is not enough to actually validate the request data. So here, if we try to send a product that does not respect that shape, it's not going to throw an error because we need to use a pipe. So a pipe has two different use cases, transforming and validating input. And the input is the one that comes from the request. So from the route handler parameters, so such as body, param, and query. In this case, body, we are expecting a product. So we need to register the validation pipe, which is a built-in pipe by NestJs. So you can import it from NestJs common. And all you have to do is just register it. Now, in our case, we're going to register it in main.ts, and we're going to make it a global pipe. So app.use global pipes, and then we create a new instance of that pipe. And what this does is it takes a look at the DTOs that we give to our route handler params, such as the body part here. And it's going to look at those decorators that you can see here. Those decorators are from the class validator package, and their role is to specify what the pipe should expect. So for example here, price should be an integer and should be between 1 and 100, including 1 and 100, because we're using the min and max constraint from the class validator package again. So do not confuse the type that we use here, number, which is for TypeScript, and the decorator that we're using here is int, which is for this validation pipe that we are using here. Now that we have registered our validation pipe on a global level and we are using DTOs with the class validator, if we go ahead and try to make a request using Postman, we got an error from the pipe, bad request. And that's because we did not respect the DTO shape. So some other key was sent, but it does not exist inside of our DTO. Now, the reason why it did not show more detailed messages is because I'm using disable error messages. So now if I remove it and hit send, as you can see, property some other key should not exist. Now, this is good if you're in development environment, but for production, it's always a good or a better way not to show the exact message. So you could maybe use some dynamic code here to check your environment, and based on that, you set this variable. I'm also using whitelist and forbid non-whitelisted, so that anytime you try to send something that does not exist inside of our product DTO, so it doesn't have a decorator specifying the type or anything else, it's going to throw an error. Because by default, if you don't have any of those, it is going to let some other key pass in within your validation. I do not really want that. It's also important to know that for everything to work correctly with the validation pipe, you need to install class validator. Of course, we've seen the decorator that this provided for our DTO, but you also need to install the class transformer package. If for any reason you didn't want to use the default validation pipe provided by NestJs and actually wanted to use a package such as Joy, for example, you can still use it with pipes to validate the data. So to create your own custom pipe, all you have to do is use an injectable decorator and then implement the pipe transform and implement the transform method provided by the pipe transform interface. And then here I have some code that I explained in more details in the pipes video, so I'm going to keep the link down below. But this way you can use Joy instead of the actual default pipe for your validations. Best practice number 2, logging. It's always a good practice to log what's happening in your application, whether it's on development for debugging purposes to catch bugs and understand how your program is behaving, or on production to keep track of the events and to keep an eye on what's happening on your server. NestJs provides us with a default logger that we can use from nestjs/common. So we can simply just create a new instance of that logger and then pass a context to it. So a context string could be anything. If you take a look at the startup logs, we can see Nest Factory as a context, instance loader, and so on. So you can choose whatever context you want your logger to have. In this case, I chose response, for example. And you can also create your own custom logger. You don't have to use the default NestJs logger. All you have to do is implement the logger service interface. And once you implement that interface, you would also need to implement log, method, error, warn, debug, verbose, and so on. Now, debug and verbose and set log levels are optional, but you would need to implement those different methods of the log service interface. Meaning you can also use Winstant, which is a very popular Node.js package, to log. But of course, you would need to make sure that you implement the correct interface, just like we said. Now that you understand the importance of logging, let's see what we have here. So I typically like to log every request made to my server and then the response time it took for that request to be served. Now you can use a middleware or you can use an interceptor. If you want to use a middleware, like my case, all you have to do is create a class, logging middleware, for example, and then implement the Nest middleware interface. You should also not forget to use the injectable decorator on top of that class. You also need to implement the use method, which takes the request and response objects and then the next function. And what I'm doing in this case is I'm extracting the method and the URL from the request, and then I'm taking the request time, so the current time in which the request entered that middleware, and then on my response object, I'm listening to the finish event. So once the response is over, what I'm doing is I'm taking the status code, and then I'm taking the current time in which the response is over, and then I'm checking the status code if it's successful, so 201 or 200. In that case, I'm going to log some information about the request and response. So for example, the method of the request and the URL, that way I can tell which API was called, and then the status code of the response and the response time. So how long did it take for my server to respond to that request? That way we can track two important events, which APIs are being called more often and which requests are taking a long time to be processed on my server. Now, if we want to register this logging middleware globally, which is the case because we wanted to be logging every single request in every module that we have, what we can do is go to app module and then implement the Nest module interface, which will provide us with the configure method, which takes a consumer of type middleware consumer. And we can apply the logging middleware for routes, and then we can pass in the wildcard, meaning all the routes in our application. Now that we have this in place, if you go to Postman and hit send, and this time the body is correct, if you take a look at the logs, we can see that we got a log here with the context response, which is the one that we set here in our code. And then we got post, which is the method. We got the URL, which is /products. And then we also got the status code 201, meaning created. And then we have the response time. So it took 6 milliseconds for this request to be processed. Just like we can log our successfully processed requests, we can also, and it is also a good idea to log our errors, which brings us to best practice number 3, error handling. Just like we can use pipes to handle and process different validation checks on our request payload, such as the body, so the parameters of a route handler like we've seen in point 1. We can also use filters to process and handle exceptions thrown from our application. So by default, Nest comes with a built-in exception layer, which is responsible for processing and handling all unhandled errors in our code. So anytime we don't have a try-catch block and we're not manually handling those exceptions, they will be caught by the built-in global exception filter, and this exception filter will return the appropriate response based on the HTTP exception thrown. So if your code throws a bad request exception, it's going to return 400 with an error or a message saying bad request. If you throw not found as an exception, then it would return 404 as a status code, and then the message would be not found, and so on. And if it doesn't actually receive an exception that it understands or recognizes, it would return this default message, status code 500, and message internal server error. But what if we could actually have manual control and override the behavior of this exception filter, and we can create our own custom exception filter and use it as a global error handler in our code? And this would be a very good practice, because in this way we actually have full control over that layer. We can log the error that we are catching in it, and we can also return a consistent error format to our client. We can do anything we want here. To create our own custom HTTP exception filter, all we have to do is implement the exception filter interface and then implement the catch method, which takes an exception of type HTTP exception and a host. And if you realize here, we are also adding the catch decorator, and we're specifying what type of exception we're trying to catch. It takes an array of exceptions. In our case, we only care about HTTP exception here. So the first thing I did is I created a new instance of the default NestJS logger, but this time without a context. And then here inside of our catch method, we can do anything we want basically. In my opinion, it's a good practice to log the error that we get and to have a consistent format for the errors that we return to our client. I'm not gonna go in details and cover every line. I have a dedicated video covering this topic, so I'm gonna leave the link down in the description. But basically what I like to do is I like to return a flag error true and then the error details that I get from the exception. You can do anything you want here. Now to register our filter globally, just like we did for the validation pipe, we're gonna use app.use global filters and then pass a new instance of our custom new HTTP exception filter. And to see it in action, I'm going to send a payload from my request body, which does not respect this product DTO, which will lead to this validation pipe into throwing a bad request error, which will be caught from our HTTP exception filter. So let's see what happens if I pass in a price that does not respect the 1 to 100 constraint. So let's say I pass -10, for example, and I hit send. As you can see, we got this error format now. Error true, and then error details, which contains the details of our error. And this is because inside of our HTTP exception, again, I am the one who specified how the error should be returned. I could have added the timestamp and anything else you might find useful in your application. We can also take a look at the logs and see that we successfully logged the error. So we can see post/products 400, which is the status code, and then the error bad request, which is the message. Best practice number 4, using guards for authentication and authorization. Now for authentication, you can probably get away with using a middleware, but in my opinion, it's better to use a guard. If you want to protect your APIs, for example, you need to have an API that only certain users can access based on a JWT token, for example, or a certain role, then this is when you should be creating your own authentication guard or authorization guard or both. To create a guard, all you have to do is create a class that implements the canActivate interface, which provides the canActivate method that you need to implement, which takes a context. And then this canActivate method is going to return a boolean, or if you take a look here, it can also return a promise of a boolean if you have asynchronous calls, or an observable that returns a boolean, such as if you're using RxJS, for example. Now, if the boolean return is true, then you have given access to the request or to the user making the request, and the request would go to the correct route handler just like it should. But if you return false, then this is going to throw a forbidden exception error, meaning 403 as a status code. Now, in my opinion, in an authentication guard, we should throw unauthorized exception instead of forbidden, because unauthorized, meaning status code 401, is usually for wrong credentials or the identity of the user. We have problems identifying the users or something. But forbidden is used whenever we know who the user is, but they do not have enough permissions to access a certain route. So they are unauthorized to enter a certain route. I explained the differences between authentication and authorization in a dedicated video. I'm going to leave the link down below, where you can also watch how we created the guard in details, because here I'm going to go in a faster way. So basically, we got the request, and then we are checking to see if we have a token in our request headers. If we don't have a token, we're going to throw new unauthorized exception, so the user does not have access to the route handler. And then if we do have a token, we're going to call a method called verify token, which is going to decode and verify that token using our secret key, which would be an environment variable. And then let's say it worked successfully, we're going to return the decoded token. Usually it's going to contain the user ID, for example. So here I'm going to attach a user object to the request, which is going to contain the decoded payload, and then we're going to return true, meaning we have given access to the user. So the request will go to the route handler successfully. Again, in case you want to see a fully detailed and fully functioning authentication guard with a full code, then in which we use the actual jwt.verify method using this JSON Web Token package, which is very popular, to decode and verify a token, in which we also check different configurations, and we use the JWT module in our application. Please check out the video in the description where we cover it fully. Now, to use our authentication guard, I registered it using use guards on top of this route handler, and then we are using the rec decorator to get the request, but I'm only extracting the user part of it, which is found here, request.user, which contains the decoded token, and then I am logging the actual user. So it should log ID 123 unless it throws unauthorized. Now, in case we send a token, if I hit send, as you can see in the logs, we got 123, everything was fine. But if we do not pass a token, let's see what happens. If I hit send, as you can see, we got error true and error details with a message unauthorized. So we can see our exception filter once again in action, catching the errors and then turning a consistent error, whether it's an error thrown from our auth guard or from our pipe or anywhere from our code. So we can see that we have a clean separation of concern in our code. Our pipe is only validating the request payload. Our exception filter only cares about handling the errors, and our guards only care about validating the token, authorizing a user, and so on. And finally, best practice number 5, using and creating your own custom decorators. So we've seen in NestJS, we use a lot of decorators, built-in decorators such as add module, add controller. So we can pass in different options, we can modify a behavior, we can pass some metadata, and so on. Just like you can use built-in decorators, you can also create your own custom decorators. A good example for that would be creating our own custom roles decorator to specify which roles can access which routes. So just like we can specify that this route handler accepts requests of type HTTP post, here we can also specify that this route only can be accessed by users who have the role of admin. Creating a decorator is simple. Basically, we need to call the setMetadata method, which returns a custom decorator. We need to pass two different arguments, the metadata key and then the metadata value. So the metadata key is the key for this decorator, for example, roles, to refer to that decorator. And then the metadata value, what value should this decorator return? Here it should be dynamic based on whatever we pass in. So if you take a look here, we want to pass in an array of roles. So our function needs to take an argument, which is roles, which is an array of strings. It could be an array of enum or anything based on your business logic or business rules. In this case, this is how our decorator would look like. Now let's see how we can access this decorator in our authorization guard. So if you noticed here in use guards, after our request goes through the authentication guard, if everything is correct and there's no errors thrown, before entering the route handler, it should also go to the authorization guard since it exists in the use guards array. So inside of our authorization guard, again, this is a template, but if you want to go more in details, you can watch the video down in the description. Basically what we're doing is, again, we're creating a guard. This time it's called authorization guard because we're handling authorization. We could also call it role guard since we're looking at the role here. Now to be able to get this roles decorator and get the metadata, meaning the value, so the array containing admin, we should use a reflector. So we can inject it here. So we're doing dependency injection here, and reflector, by the way, is from NestJS core. I'm not going to go too much into details, but basically here we are getting some metadata using this reflector from a target, which is the get handler, because we're using this decorator on top of the of a route handler, basically, which is create product in this case. And then those would be the required roles for this route. So whatever we get here is the required roles. If we don't have any required roles, then we can return true because there's no role specified for this route. And then I'm going to log those roles. Again, I'm going to get the request, and this time I'm taking the user from the request.user. Now, don't forget, request.user has been assigned here in our authentication guard before. So anytime we want to call our authorization guard, we need to make sure that we are applying our authentication guards first, just like we did here. Use guards, we specify the authentication guard and then the authorization guard. What we're doing here is I'm getting the user. If you don't have a user, then something is wrong. We probably didn't go inside of our authentication guard, so I'm throwing an error, unauthorized exception. And then what we need to do is get the actual user role from our database. So here I made a function. It would need to have a logic, and then it would end up returning some role from your database based on the user ID that you have from the user, from the request.user that you attached earlier in the authentication guard. And then using this user role, you can compare it to the required roles coming from the metadata from the custom decorator. That way you can tell if that user had the correct role and has access to that route or not. Let's go ahead and see that in action. If I hit send, if you take a look at our logs, as you can see, first of all, we got inside authentication, and then we got inside authorization, so the authentication passed. And then inside of authorization, we are logging the required roles, so the metadata from the roles decorator, which is here on top of the route handler, it said admin. And then we logged the actual user ID that we have, or the user object that we have on the request, which is ID123. And then we have printed the actual user role from the database, which is admin from here. Since it matches the route role, we can see that we got a successful response. Now let's say we returned user, for example, so the user role in the database is user and not admin. If you hit send, as you can see, we got an error here, status code 403, meaning forbidden, and that's the error here. And the message is user does not have the required roles, which is the message that we have here inside of our authorization guard. So now you can actually see how everything is working smoothly. We have separation of concern. We are using guards to authorize and authenticate a user. We are using pipes to validate the request payload data from a body, from a query, or anything. And we are implementing logging. So anytime we have an error, we're actually logging that error. And we are also implementing logging for every response. So anytime we make a request, we are able to see what request was made and then the response time it took. And we have also seen how we can return a consistent error format to our client. Those are some of the best practices that you can follow in NestJS to keep your project clean and be on a good track. Of course, there are more like dependency injection, keeping your code modular, decoupling, and so on. If this video gets a lot of interactions, likes, and views, then I might make a part 2. So make sure to share, like, and subscribe. Thank you for watching, and I will see you next time.